Hey guys, welcome back to the CodeMat. It's a day 15 from the June LeetCode challenge, and today's problem is a search in a binary search tree. So in this problem, we will go through the problem description, we'll understand the examples, and also we will write a code and understand the time complexity of this problem. Before we proceed, if you are new to the channel, please subscribe to the channel. We solve a lot of competitive problems which can be helpful in your upcoming interviews. So let's get started with the problem. In the problem, it says given a root node of a binary search tree and a value. So these are the two parameters we have given in the input. You need to find a node in a BST that the node's value equals to the given value. Return the subtree rooted with that node. If such node does not exist, we need to return a null. So now let's understand with the example. Here the binary search tree BST tree is given to us, and the value we would like to search is a 2. So the 2 value, the node itself is present, so we have to return this subtree. All right, from 2 1 3, this is what the output we would like to return. In the example above, if we need to search value 5, since there is no value as a 5, we need to return a null out of it. All right, so one thing we know in the binary search tree, it has a properties like from the given node. Let's say if we are at a root node, it has all the numbers on the left hand side will be lesser than the what you have current node, and the same way on the right side, all the nodes having a value higher than what your current node has. And this 2 rule will apply at each node. So if you are at a root, all the subtree nodes from the left hand side should be lesser than the what you have at the root, and same way for right also. All right, and same applies at 2 also. On a left hand side, it will have a lesser value as compared to your root node, and on right side it will have a higher value as compared to your root node. Okay, so if you see here, we would like to search this node. All right, so we know that our given tree is a binary search tree. Okay, so we can apply a binary search logic to this tree, and we can iterate over from the root node. So what logic we will apply here is, let's say when you are at a root, all right, so we'll check with the current node with the given value. Okay, let's say if that value is matched with the current node, let's say we are looking for 2 and you are at a 4. Okay, we start with a root. Now let's say if it is match, then we will return that node itself, because in that case we would like to return that node itself when we found it. All right, now let's say if we haven't found that node, it is not matching, so in that case we will see whether that current node value is higher or lesser with respect to the current node. Then only we can search whether we need to traverse to the left subtree or a right subtree. So now let's say here the root node having a higher value, that means whatever the node we are searching for, that lies on a left subtree. We do not need to go to the right subtree, because right subtree having always a higher value with as compared to what we have root now. So we will move to the left subtree only. Now let's say we move to the left subtree. Now we are at a here, so again it checks for the whether value having the same or not. Now in this case it's having the same value, so in that case we will return this node itself. That gives this subtree in the result. All right, let's say if that is also not the case, let's say we are searching for 5 here, so in that case we will go through for 5, we will start from the root. All right, and we will search with the root node. So 5 is a greater than the what you have in the root node, so we will try to search on the right hand side. All right, and we will keep going until we found it. Let's say if we haven't found anything, then we will return a null from that tree itself. Now let's write a code for this. So here the one base condition, let's first write it down. So let's say if our root is equal to null, that means we reach to the leaf node, or node do not have any other nodes out of it, so we'll return null from there. All right, next if we'll first check whether what we are looking for we found or not. Root.val is equal to given value, then return root node. Else if, let's say else if we will check whether we need to go to the left side or right set. So if your root is higher than your given current value, then do a recursive call on a left subtree. So go to the root dot left and pass a value, and here we would like to return the whatever the result that recursion call returns, we would like to return the same value. Now else, in the else case, we would like to explore right subtree. Okay, root dot right and value. So this way we will get the correct result which we are looking for. All right, now let's compile it. Okay, it got compiled. So we are looking for 2, and this is what the subtree of 2, and that is what the expected one. Now let's submit it. All right, it got submitted. So here time complexity of this problem is, as we are applying binary search, so it is going to be log of n, and the space we are utilizing a constant space, so it is going to be constant space space complexity. So that's it in this video. Hope you like it. If you have a different solution, please write it down in the comment. If you are looking for a solution for a different problem, I would suggest to write it down in the comment box. See you soon. Till the time, bye bye.